As any model maker, craftsperson or sculptor knows, painting an object can be a bit of a hit or miss affair. Stick around and learn how you can 3D print an amazing geared turntable jig that'll help you to produce professional paint jobs on your objects with ease. Printable Science presents a 3D printed geared turntable printing jig. In an earlier video, we introduced our jig for producing professionally painted tubes and cylinders, and there's a link to that video up here. Of course, there's a lot of other things that need to be painted as well, and even a simple geometric shape like a cube or cylinder can hide annoying pitfalls for the novice. If you place your object on a tabletop or flat board, then you have to walk around it, which is fine if you're doing it outside, but inside you're going to be blowing a lot of paint around in a lot of different directions. One solution to the paint spray problem is to put your object on a turntable. And that allows you to set things up in front of a box or in a box, and you can rotate the cylinder as you paint with the box capturing the overspray. One drawback to that approach is that you often create a paint weld along the bottom edge of your object that can sometimes stick to your object and stick it right to the turntable, making removal difficult and sometimes impossible without damaging the paint layer you just applied. Now, a solution to that problem is to create a little pedestal for your object to sit on that raises it up above the turntable or your surface platform, and if you make sure that the size of the pedestal is smaller than the bottom of your object, then there's no pedestal surface shared with your object that's going to get painted and possibly glued together. But the one remaining problem that's difficult to solve is that you rotate that turntable by hand, and so you've got to put on a glove or something or employ some way of shielding your hand so it doesn't get covered in the paint while you're painting your object. Now, this is where the Printable Science geared turntable painting jig shines, because there's a pair of miter gears that allow you to rotate the center spindle of the jig from a handle that's outside the painting area, so that you can paint to your heart's content without worrying about getting paint all over your hands. The jig is adjustable so that you can have the handle as far away from the printing surface as you like, as little as half a foot or even as far as 2 or 3 feet away. The distance you select will depend on the size of the object you're painting. Now, in its basic assembled form, the jig supports a vertical shaft that has a 7/6 of an inch hex knockout surrounded by a 1/2 inch diameter cylinder. We've provided a number of different sized platters that once printed can simply be slipped onto the shaft, and once you've tapped or tacked your object into place, you're ready to go. We printed the jig in PLA for a 0.4 millimeter nozzle, 2 perimeters, 0.2 millimeter layer height, 3 bottom layers, 3 top layers, and for all parts except the bolts, we used a 20% infill. We recommend you use metal 1/4 inch diameter bolts for your assembly, either 1/2 inch or 3/4 inch long, but you can simply print them off from the supply files, and in our model here we actually use the bolts that we printed off. But if you do go the route of printing your bolts, print those bolts at 80% infill. The jig is composed of 2 blocks, one which is at the handle end of the jig and remains static, and the other which can be moved freely along the rails until it is fastened in the place you like. For the jig rails, we used 1/2 inch EMT pipe, which is very cheap and available at your local big box hardware store, but that too is optional. If you want to use your printer to print off your own pipe sections, just follow the link up here, which should give you all the information you require. The jig also requires a 3/8 inch diameter drive shaft, and we printed off the sections we needed, but you also have the option of just using some 3/8 inch diameter wooden dowel or steel or aluminum rod. The blocks each consist of 2 pieces. That's only because we've designed this jig so that even if you have a printer as small as a monoprice Select Mini, you can still complete this project easily. The head block consists of a square-shaped lower piece that's identical to the other lower piece, except that the bottom holes for the rails are blocked off. Once you're sure you've got the right piece, you'll take the smaller triangular piece and slip that over the posts in the top of the block. You may want to use a little epoxy to prevent these two parts from coming apart. You might want to check out the link up here. It's a simple project for creating an epoxy workstation that will help you in all your gluing tasks. You can then assemble the tail piece or tail block, taking the lower piece and slipping the second larger piece over the top post. Once again, you should probably use a little epoxy to keep the parts from slipping apart. At this point, you can slide the rails into the handle block. Bottom the rails in the socket and then use the bolts to fasten them in place. Remember, these rails can be as long as you want, and the longer they are, the further away you can set your handle from the spray area. In this assembly, we're just using foot-long rails to give you a better idea of what the assembly looks like. Now it's time to fasten the vertical miter gear in place. You can tell the difference between the gears by the amount that the center cylinder extends beyond the top of the thread. The center cylinder of the vertical gear is flush with the top of the threads. Take a 70mm long 3/8 inch diameter rod. In our assembly, we took one of our extension pieces and just cut off the top. If you're using a wooden dowel or metal rod, you can cut the length you require. Holding the miter gear in place, that's with the teeth pointing down, slide the rod in through the top hole, through the hole in the miter gear, and into the socket in the block. Now take a bolt and tighten the gear onto the rod. Check to make sure that the rod spins freely. You can now slide the block onto the rails and fasten it into place, choosing a position that's more or less where you think you're most likely to be using it. At this point, all you need to do is take a rod that's as long as your rail and put it into position. Start by sliding it in from the opposite end of the jig, and as soon as it is through the bushing, slide it in through the other miter gear. Then slide the stop collar onto the rod, and then slide the rod through the bushing in the handle block and slip the handle onto the rod. Because we printed our center shaft in sections, you can see we need to change the assembly order a bit in order to accommodate the bulges in the shaft. Now first you'll want to make sure that the rod is fully pressed into the handle. Then take a bolt and tighten it into position. Now push the handle forward until it is flush with the mount. Holding it flush with the mount, move the stop collar into position and using another bolt, tighten it in place. Now all you have to do is move the miter gear into position so that its teeth mesh with the vertical miter gear and tighten it in position. Adjusting your jig is simple. You simply loosen the horizontal gear nut and the block nuts on the rail. Then you just move the block to wherever you want to. Tighten up the bolts, move the horizontal gear into position until its teeth mesh with the vertical gear and tighten it in position. At this point you can drop the shroud into place, which is kind of disappointing because it's always fun watching gears work, but if they aren't shielded, they'll get all clogged up with paint and get stuck, and you won't be able to use it in virtually no time at all. Don't worry though, we have a project coming up soon that has lots of gears that you get to look at all the time. The last step is to simply fasten the upper axle in place with a final bolt, and now you can just drop in a platter that suits your requirement. So there you have it. A 3D printed geared turntable painting jig is all ready for work. Thanks for watching, and won't you help by becoming an important part of the Printable Science family and making this channel more valuable and successful. You can help us out by taking the time to watch this video in its entirety and other Printable Science videos as well, perhaps while your 3D printer is printing off this project. You can leave comments and questions below. That will help us to continue to create useful videos and 3D STL files that are printer ready and help you to maximize the power and utility of your 3D printer. Your feedback is very important. If you've enjoyed this video, please click the thumbs up button, and if you have just a moment, won't you show your support by clicking the subscribe button below. If you want to make sure you don't miss our upcoming videos on 3D printing, you'll want to click on the notify bell as well. And please, consider supporting Printable Science on Patreon using the link supplied below. You can become one of our Patreon supporters for as little as $1 a month, and it'll provide you with lots of extras and additional information, as well as going a long way to defray the cost of making these files and videos. Down below, you'll also find a link where you can download a copy of the STL files from Thingiverse so that you can make your own 3D printed geared turntable painting jig. As always, you can download a copy of the STL files for this and other projects directly from our website. The latest files and a discussion board on our 3D printed geared turntable painting jig are available at the printablescience.com website, where all the science that fits we print.